Hello everybody, welcome back to another episode of Kerbal Space Program. And today episode we will be checking out some contracts. Active contracts, okay, Lunar Orbiter. That's pretty easy to do, I think. Let's see. Alright, so we are going to be building a probe that goes into the orbit of the moon, and 3.5 tons is a lot, bro. Holy moly. We're not going to be sending that heavy stuff. Okay, we haven't unlocked the avionics yet, so I'm just gonna go back and then unlock those first and then come back and build it. Okay, research and development. I think I should unlock the solid boosters because they are very useful. And let's see. Yeah, I think we've unlocked everything. Pioneer adjustment motor. Oh, 60 Newton. Well, huh. It's not a lot of thrust, to be honest. It's not a lot of thrust, but that's probably used for course correction. That's very weird thing to use, but okay. I'll take it. Communotron. Ah. Ah. Okay. Yeah, these are interplanetary stuff. We're not gonna be focusing on that for now. We're just gonna be focusing on the the getting to the moon first. Research going on, and I think I'm gonna have to hire some researchers real quick. Let's see. Let's go to 2 science per day, and that should be pretty quick. See, when we have unlimited budget, we are able to do all of them ASAP. See? Tell me that's not awesome, huh? Tell me that's not awesome. This is what NASA would have looked like, or actually the world if they had collaborated and worked towards, you know, building a common mission project or something, you know. That would have been awesome. Pulling together resources and all. Damn. But I don't think we'll be able to see that in our lifetime. Of stupid politicians. Okay, where is the satellite again? Uh, it's way down there. Yee. There we go. Alright. So let's make this super duper light. So deep space, basic avionics, unlock that, and damn, that's heavy. Damn, that's heavy. Let's see, 10,000. I mean, battery's gonna be really heavy, that's for sure. And how small can I make this? Blue dog. I want to make this look like a Sputnik V. Yes. Okay, this looks more like an actual awesome satellite. Okay, 300 kilograms. Okay, cool. I don't think I can go sub 1 kilograms. You know. Oh, I can set the controller mass to sub 1 kilograms. Okay, but I think 1 tons is the sweet spot if you ask me. Okay, so there's that, and now we are gonna, man, 300 kilograms is heavy, sure, but let's see. Stored oil tank, how about that? And then use something like hold on, I can just use solid rocket boosters, right, to get into orbit. We don't really care about getting into orbit, like exact orbital maneuvers. We can use thrusters too, that's also possible. But why would I want to use them? Like that's just basically like using RCS, right? Oh my god, the thrusters are so inefficient. But that's nitrogen stuff. If we just use something like this, the vernier engine, we can also use that. The vernier engines. Oh man, that would be so stupid. Why would I want to do that? We can, if you want to. Definitely can. Okay, so these are thrust. Okay, wow, these are controllable engines. XLR25, S155. Ah, okay. We can use this to land on the moon. No joke. Because these are thrust controllable engine. Not a very efficient engine. I think we're just gonna go with um solid rocket boosters because they're very cheap and I don't have to worry about ullage, stuff like that. So there we go. How much delta V would that give me? 151. That is honestly not a lot. That is honestly not a lot. I think thrusters would be fine, honestly. But man, single thruster, I don't know. Is there an extra tank that I can use? Not quite. Oh, this battery too? Yo, okay, let's go with battery 2. Let's go. 25,000 electricity is 72 kilograms, which is nice. Gives more weight. And let me turn off the antenna of this thing if there is really. Oh, magnetometer, right? Yes, let me include that here. Because it's way too huge to be, included there. And then I think orbital petrofusion or something, but we haven't unlocked that yet, so I guess we can put that on the outside. Okay, now for the fuel, I'm thinking about using some total tanks. Just because why not? And then just okay, no, not conventional isogrid stuff. And then just go with high pressure isogrid tanks. And then how much time would it even take? Wait, how much thrust does it give? 40 newton, 86 newton. If I switch to HTP 193, 201, hydrogen a bit better. But we haven't unlocked that yet, so nitrous oxide. Gonna be using nitrous oxide, okay. Doesn't show any delta V though. Because we need to fill this up with fuel in it. Okay. Thrust weight, okay. 105 meter per second. That's honestly is not a lot. And 144 vacuum ISP. Oh man, okay. You know what? I'm just gonna carry around this thing with me. I can just use this as a RCS. Won't be able to do any course correction or anything. And how heavy this thing is, yep, 0.05. So that's not that heavy. Sure, it is a little bit heavy, but not really that heavy. Yeah. And then like I could carry around let's see. How about this? 151. Okay, that still is a lot, to be honest. 600. Okay, I don't need too much. Okay, this thruster I think we can use. Can we? But remember why I didn't want to use it in the first place? Inefficiency. Screw this. It is inefficient, but the engine is heavy. I don't want the heavy engine, engine to be too heavy. So yeah. There we go. Thrust to weight ratio is less, but I don't think it will cause much issue. I think 300 will be enough to get into orbit. There we go. And oh god, what is this? Okay. Wow. Dang. What even is that? Bruh. Is this some kind of joke? How about spherical tanks? I suppose they are pretty decent. Okay, yeah, they're pretty good. They're pretty good. Can tighten them up, and then yeah, there we go. There we go. All right, sweet. And then I can just slap some RCS up here, just like that. Make it a 4-way RCS. Gemini. Huh. I don't think I need that many. I can just make do with 3. And then we can change the engine to nitrous oxide. There we go. Okay. Okay. That's pretty good. We have RCS, we have control, so that's good. Let's look at the mass. We don't need that heavy. Okay, so let's see our electrical stuff. So I think we're gonna be putting a ton of solar panels on, just because why the freak not? It's cheap, it's not that expensive, so let's go with solar panels, a ton and ton of solar panels, because why the freak not? And then let's have an antenna. Bam. I don't care about the power uses. We're gonna be using a ton of power, man. I just want the signs to be there. Okay, there we go. I think I can disable the antenna, the internal antenna, if I wanted to. Really, can I? Have I filled it up? Yeah. Yes, that saves a little bit of mass too. Oh, a little bit of money as well. 0.468 46. Oh wow, that's actually saved me like 8 kilograms. Yeah. Okay, I'll take it. That's extra delta V for us. Oh, I lost some delta V. What's it because of the RCS? No, it's probably because of the extra solar panels that I put. How about we increase the size of it? Nah, but that was increase the size of everything. I don't want to increase everything. Okay, so next up would be experiments on board. Or orbital petrovision. We can do this one as well. Inclination. Oh, there's an inclination requirement. How heavy this thing is? 0.001. So yeah, not that heavy. It's not that heavy. We can include this, as well as all the other typical experiments that we run. Obviously, throw all of that on the spacecraft. We also have some big ones like this infrared radiometer that we're obviously gonna include, but inside 0.5. I think that saves a bit avionics. Wait. Yep. Configure experiments. Let's see, infrared. Maybe it's not unlocked yet or something. Okay. I think I can unlock it later. Sure. Planetary photography. I wonder if I can fly this to the moon and then bring it back. Oh man, that would be so interesting to see. That would be an interesting mission, right? I think we have everything. Aside from some experiments like the petrobration and the infrared thingy. Don't worry, we'll go back to the moon again sometime in the future, and then maybe then we'll grab extra experiments. Yeah. So it's currently less than the weight limit, so we can still take some more stuff if we wanted to, but I'm not gonna take more than I need. Not gonna take what I don't need. There we go. It's probably going to suck trying to get into orbit. Look at the delta V. 26, 29. Yeah. This thing isn't gonna cut it, to be honest. Here I expected that to happen. But I did unlock new Ep7, so that increases not the thrust, but okay, it decreases the efficiency. Wow. Okay. What we get in return is extra burn time, so more uncertainty, whatever you wanna call it. Yeah, really, it's bad. So here's what I'm gonna do. I'm gonna bring along the avionics unit. Okay, we're not gonna save on the mass. Okay, we're not gonna look to save on the mass or anything. Oh, technically I could save on the deep space avionics, but it's not worth it probably. Okay, it's probably not worth it. There we go. Maybe I should put it somewhere else, like there, for example. Okay, I'm gonna swap out the engines because there's no way I can get to the moon with this now, because the stuff is getting heavy up there. Instead, what we are going to use is our trusty upper stage. Oh wait, there are some upper stages that we could use. For example, this thing. But no, I'm not gonna use inefficient stuff. Here it might be not that heavy, 0.3, but we can just use the RD105. Where did it go? Oh, we can also use the Agena engine if we want to. Where did the RD engine go? Okay, 0.127, 0.0. Okay, 0.12. Okay, this is heavy. This is not that heavy. 9 liters, 5 liters. Irfana liquid oxygen. 11 liters Irfana, 9 liters liquid oxygen. And well, this is more powerful, but it just cannot beat the efficiency of the RD1 of. Okay, yeah, let's go with this one. But this is not restartable. That is something to consider. So there's a lot of things that you have to consider while building a rocket. Yeah, compromise a bit of efficiency for restartability. Yeah, stuff like that. Hold on, I think I'm gonna have to increase the diameter for this thing to, yeah, that. And while S4V mount is nice, I don't quite like it, to be honest. Once we have everything in the RCS with us, this is gonna go heavy. This is gonna be heavy, guys. 8.9. Are you kidding me? That's heavy. So if you look here, okay, 6 minutes of burn time, which is actually less. Okay, we can burn more if we want to. So let's go to basic avionics, the new one, which allows us to be a bit more heavy. Get some heavy stuff up there. And maybe reduce some power usage on the way. There we go. Okay, that reduced the power. There we go. Okay. 8.3 tons, still quite heavy, but it's fine. I think we can just add more 4 of these boosters down there, and we'll be able to get this thing into orbit, no problem. But if you look at the delta V, it's already way too high for what we need for a moon mission. So we can just compromise on the tanks, to be honest. We just need 3400 for the mission, and there we go. We're 5 tons. Okay. Yeah, that would be enough. Okay, it's still way too much. Definitely. But yeah, there's not much we can do. So I think this is good enough for what it is. Obviously, we're gonna have to add some boosters down there because there's no way we're gonna make it into orbit. So maybe 4 boosters or 3 boosters. Like we are able to get 3 tons easy peasy right now. Maybe adding another one might be able to get us to places. We're gonna have to check it out, but to be safe I'm just gonna put 4 because I don't care about the money, remember. Care more about the mission, the science, not about the launch vehicle. So there we go. Maybe we have to tool stuff. 16. Yup. Okay, everything looks good. Why doesn't the fairing go back? There we go. Fairing is light enough, I think. And yeah, that's it. I think I might need structs to make it, well, stable, I think. Do I have to? It's nice to do that. Nice to have, I guess. Alright, so I need to get the engines in order. So there we go. The booster separate along with the fairings. That's the bottom part. And then booster, fairing, payload. Right, payload. We need to be in the same order. And then the actual payload to the moon. Okay. The payload to LEO and then the actual payload to the moon. And I think I can just increase it, but nah. 50. Let's go to 50. A little bit of extra delta V does not hurt to carry around. And let's see, can I increase the efficiency of this engine? Okay, I'm using this one, which is 3247. I can sacrifice everything for less weight. Nah, more less weight but more efficiency, higher burn time. Okay, so that means more delta V. But I think the future ones will have longer burn time if you want them. For now, I think this will work fine. So let's not change any configuration or anything and just build it. And oh boy, we need to modify the launch complex because this has surpassed the weight limit to 63 tons. I think if I add a upper stage over here, it will eventually go to 300, to be honest. So yeah, I will be doing some heavy stuff soon, very heavy stuff. So definitely gonna Yeah, love that. Modify. Hopefully we're fine on the height. Alright. The moon. Ascent guidance. Launch into the plane of target. Engage pilot. And there we go. I think like the most of this part of the mission will be automated. We just need to click some few buttons and we'll be on our way to the moon. Yeah, that's easy as that. It seems like it's gonna be a night launch today. Alright. Lift off. And avionics is insufficient. Dang it. Alright, let's go. I let it burn the first few seconds. It burned straight and then went like completely horizontal, which is fine. Maybe we lost few efficiency, but this rocket was already over engine. Remember, while building, I added extra boosters just because of that reason. Yeah. Alright, we are in orbit. And now we will, I think, stage. But first, let me create a burn. Yeah, I do want to do a capture burn, so. Is that the best we can do? Okay, we have enough fuel, good. Execute. And then we are gonna time warp towards where there is light. Stage? Stage. Dang it. We don't have communication here. Oh, dang. We will have to get a communication satellite up and running, you know? Communication network. Because not having communication is bad. Okay, stage. RCS. And execute node. We do fast forwarding. Now this part is very easy because of MakeJeb. It will automatically align towards the monument road, create it, do the calculation for the burn, and then automatically start the engine. There's also one bonus feature. I'll show you soon. So you see how it automatically, gets us to the place at the monument node. It also performs the most efficient burn. That is half burn before the node and then half after the node. And then it also it also takes care of alleging the stuff itself. See, as easy as that. Now since this was MakeJeb, everything was set up, we did not require any connection. So back on Earth, the mission control probably is thinking like hopefully the burn is proper, the burn is successful, and the probe is on its way to the moon. That's what probably the people are thinking, but oh well. Now the good thing about having engines on the probe itself is that we can perform course corrections if we wanted. So yeah. Also there's a lot of power coming in. Yeah, so we can run the experiments. So actually it's a good idea to start all of them while we can. There we go. Oh, let's remove it. And I think we did a perfect burn. Okay, it's fine. We can just do some correction. Looks like we're gonna be on the dark side of the moon, huh? I think I can just burn extra. Yeah. I can just use the RCS on this thing and then make sure that we get... Huh. Can we get a periapsis that's like on the bright side of the moon? I think that is possible. Let's see. There we go. There we go. Okay, that's actually pretty nice. Wanted to go even more further down, but okay. I think I'm gonna have to be happy with this. Whatever we have. And we don't need to spin stabilize anything. So that's nice. That's really nice. Now that, because of that, we can start some of these experiments right now. Gather some extra data while we're back. Now way there. Okay. That. Everything looks a-okay. We have communication and 31 kbps. Wow, that's actually pretty good. Very good. All right. Where is the moon? Okay, there's the moon. All right. Let's see, maneuver node. I think I'm gonna have to decouple first. Can't decouple, man. Low. Oops, you did not see anything. Just ran out of some power, basically. That was my fault. I was too careless, too greedy for experiment. Alright, I'm so stupid. I had accidentally shot down the avionics. Because this is deep space avionics, they are controllable. So it's a net loss right now. Dang. Because of all the experiments that we're running, probably. Damn, even that much is not like enough power. Wow. I thought this was like a lot. We had a lot of power in that. Seems like that's just not the case. And this will also generate a little bit of extra power, but it just ended up being dead weight, I guess. Yeah. Okay. That's fine. That's fine. I'm not gonna send back anything. So, oh, I can just shut down the avionics, bruh. How did I not think about that? And that's, yes. Okay, so I have extra power now, and then I can now start sending back the data, as well as start all the experiments that we have on board. Yeah. Okay. Nice. So let's see. I had orbital perturbation thingy. Not sure if can run that. Yeah. Inclination. Okay. It's fine. But 330 signs? Oh my god. I need to have that on Earth. I gotta send something up there. Yo. That's actually pretty insane. I can actually send the Lunar craft in Earth up. Yikes. Does it actually not care about Let's see. I'll have to check that out. Oh dang, invalid situation. Okay, so I'm just gonna wait for the science to come back, and we'll send up another mission. And I think I wanna have something that goes like this, another orbit that goes through the dark side of the moon and has something like that, so we can have two different probes, sort of acting as a relay for each other, so we can have constant communication around the moon or something like that. I don't know. That's right. We're orbiting. Luna 10 was the first ever human-borne object to successfully orbit the moon. Wow. I want to see how they did it and actual data behind. Okay, yeah, that's interesting. One research topic. But I think we finished our program quite early. So let's go ahead and finish it. And that just unlocks a whole bunch of stuff. That's interplanetary stuff, bro. Okay, it's gonna go over my mind. So I'm not gonna focus on the stuff. Let's think about something near us. And I want to send there. When I do send something there, it takes a long time to reach. Like sending up to the space is not a problem, but reaching there is a problem. So yeah. Nuclear research speed. Yo. Okay. Okay. All right. That is interesting. I think RP1, RP2 also had some nuclear engines. I don't know. Anyways, commercial application, which is Molnia. Okay, this one takes time to finish. Okay, I'll play this one maybe later when I have really good engines that can restart again and again. Because getting 3-4 satellites into different orbit is no easy task. So I think we'll do the early observation satellite. So I think I should be able to do this easy peasy. But I think I'm gonna end this episode right here because this episode was a moon special episode. Only focusing on the moon stuff. With the sweet science returned back, I think I should be able to unlock more orbital rocket. Ah, XLR 99 space plane. Ooh.